Question 5. So part A, are forces scalar or vector quantities? They are vector quantities, and the reason they're vector quantities is because they have both size and direction, and it's direction that is the key thing. Scalar quantities only have size. Complete the label on the upward arrow. Well, there are lots of choices here. You could have had drag, resistance, force, push, thrust. Didn't accept pull as the force there because the air resistance is pushing against the parachutist. And the second part, we could have had the air, the atmosphere, air resistance, or drag. So the graph is a velocity time graph, and it's showing that the velocity is increasing until it reaches a maximum constant velocity. That is the terminal velocity, and if you read across on the x-axis, we can see that it's exactly 56 meters per second. No other answer is acceptable. You didn't need to write meters per second to get the mark because that's already on the answer sheet. So part D, what is the relationship between the two forces on the skydiver? Before she reaches terminal velocity, you can see that the velocity is increasing, so therefore there must be an acceleration. Therefore, the forces are unbalanced. That means that the pull of the Earth, or the weight, or the gravitational pull, or the downwards pull must be greater than the upwards push, which were labelled earlier. And part 2, when she's travelling at terminal velocity, she is no longer accelerating, so therefore the forces must be balanced. So what you need to say is that both forces are the same or equal, or there is no resultant force, or the resultant force is 0. And for part E of the question, it's asking you to add a line to the graph to show how her velocity changes as she opens her parachute. So she opens her parachute and the velocity is instantly going to decrease. So on the graph we're showing the velocity going down quite rapidly, but then the rate of decrease declines until she reaches a new lower terminal velocity. So although my sketch is very rough, you can see a decrease in velocity and then you can see that levelling off. Now what the question also asks is that she reaches a new terminal velocity 10 seconds later. So what you needed to show is that this area here, around 35 seconds, the decrease is finished. It's not very clear from my graph, but that's what you're supposed to have. It's stopping the decrease at 35 seconds. And the final part of this question, explain why her velocity changes in this way. Now this is a 3-mark question, so you must have 3 sensible, distinct, different marking points to get the marks. So what you needed from this was 3 of the following answers. You could mention a larger surface area, you could mention that the air resistance increases, and then you could compare the two forces, saying that soon after opening the parachute the upward force becomes greater than the downward force. You could mention that the parachutist's velocity decreases or she decelerates. You could mention that as she decelerates, the air resistance decreases, and you then should say that the forces eventually become balanced.